Today's focus is on converting functions. Now we're going to be converting between standard form, vertex form, and intercept form. And one of the things you'll notice is standard form is the centralized, everything revolves around it form of writing a function. So we can go from vertex form to standard form back to intercept form, or we can go from intercept form to standard form back to vertex form. But you don't really transition from vertex form to intercept form. So what do we need to know to transition to vertex form? You've got a couple of options. We need to know the vertex. But what's probably going to be more helpful is how to write a perfect trinomial. Now, you may recall that we wrote perfect trinomials back when we were working on completing the square. So a lot of your process and what we do is going to seem very similar to completing the square. Now, what do we need to know for intercept form? Naturally, we need to know what our roots are. Once we know our roots, we simply list them in order, and that is our intercept form. Now, we're going to talk more about what we do as we work through the problems, because it will make way more sense if I show you what you do rather than me just telling you right here on this screen. So let's start with converting. What form are we currently in? That's right. We're in intercept form. We can tell because we have our factors already identified here. And so we can quickly figure out what the roots are for the intercepts. In order to go to standard form, that's probably going to be one of our easiest transitions. We simply FOIL. So x plus 4 times x minus 10. First, x squared. Outer, negative 10x. Inner, positive 4x. And last, negative 40. And then we can combine our like terms. So x squared minus 6x minus 40. And we have completed standard form. Now you'll likely remember that I told you on the previous slide, everything revolves around standard form. So in order to get to vertex form, we're going to start with our standard form, x squared minus 6x minus 40. Now, if we were completing the square, we would take the minus 40, our c value, and we would move it to the opposite side of the equal sign. This is similar to completing the square, but not quite the same. It's similar in that I am going to create a perfect trinomial. So x squared minus 6x, leave a little bit of space for the trinomial, because our trinomial is going to go inside the parentheses, and then we're going to subtract the 40 from it. So far, I haven't really changed the problem. All I have done is put parentheses around this portion of my problem. Now to create the perfect trinomial. Remember that when we were creating perfect trinomials, we took half of the b value and squared it. So half of negative 6 is negative 3. Negative 3 squared is positive 9. Now, if we're trying to keep our scale balanced, remember, everything we've done so far is on one side of the equation. So we have just added 9 to one side of the equation. It's going to make my scale unbalanced. In order to keep it balanced, we would typically say, just add 9 to the other side. That keeps it balanced. But that's not really an option for changing to vertex form. So instead of adding 9 to the one side, we're going to go ahead and just subtract 9 from the other side. Well, that makes sense. 9 minus 9 is 0, so we really haven't added anything to the equation. But notice where I'm going to subtract 9 from. I'm going to subtract the 9 outside the parentheses. Well, why? Because I have a perfect trinomial that I want to turn into a binomial squared. And since it's a perfect trinomial, we know the binomial squared would be x minus 3 squared. Well, we're starting to look like we're in standard form already, aren't we? The only thing we need is a equals f of x, and we've got to figure out what to do with the remaining of these values here. Well, negative 40 minus 9 is negative 49. So we've cleaned up this entire problem and wrote it in vertex form. Notice that the vertex is the opposite of -3, so 3, negative 49. And we were able to find that vertex really quick and easy. So that is vertex form. Let's recap what we did. We put parentheses around the first two terms, spaced it out so that we could had a room for creating a perfect trinomial. We added 9 and subtracted 9 from the same side of the equation at the same time. And then we used our perfect trinomial to make a binomial squared, and we combined our two like terms. Don't worry, we're going to be doing lots of these today, so you'll get plenty of practice. Let's try another. Well, we're in standard form. So in order to get from standard form to intercept form, we need to find our factors. So I need two numbers that multiply to 16, add to negative 10. Well, 8 and 8, no. 4 and 4, no. How about negative 2 and negative 8? Well, that seems to work. All right, we got negative 2, negative 8. That is, in fact, negative 10. So I could now say x minus 2, x minus 8. Those are my factors. Well, that's what I needed for intercept form. So f of x, g of x is what we were given, is equal to x minus 2, x plus 8. We're in intercept form. Now let's go to vertex form. You cannot take your intercept form and go to vertex form. We've got to come back up here and take our standard form equation. So x squared minus 10x plus 16. And I want to first put parentheses around that so that it reminds me to space it out. X squared minus 10x. Leave a space for my third term. Put the positive 16 outside still. All right, let's make our perfect trinomial. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. Now I have added 25 to the right side of my equation. I'm going to subtract 25 from the right side of my equation. That way I have added 0 in totality to the right side of the equation. We'll make our binomial squared, so x minus 5 squared. And we're going to combine our terms. 16 and negative 25 gives us a negative 9. So g of x is equal to x minus 5 squared minus 9. Again, we could identify the vertex really quick. Opposite of inside, 5, keep the outside, -9, and we're done. All right. This time I'm starting with the vertex form. So the very first thing I'm going to have to do to try to get to standard form is FOIL. X minus 3.5 times X. Sorry. Why did I put a minus? Where's my... X minus 3.5. So that's going to give me X squared minus 3.5X minus 3.5X. And then we want to know 3.5 times 3.5, which gives me 12.25. So altogether we have X squared minus 7X plus 12.25. Now notice that's just the binomial squared. That's only this portion of the equation. We had a minus 30.25, so I want to add that back onto the equation, so minus 30.25. When I subtract 30.25 from 12.25, we end up with negative 18. So negative 18, negative 7x, x squared. That looks to me like standard form. So let's go ahead and give it our h of x is equal to x squared minus 7x minus 18. Now to go to intercept form, we can find our factors, negative 18 and negative 7. That would appear to be a negative 9 and a positive 2. Does in fact add up to negative 7. Does multiply to negative 18. So we would end up with an x minus 9, x plus 2, and we're dealing with an h of x equation. All right, let's try another one. Converting to vertex form. We're in standard form now. So in order to get to vertex form, I want parentheses around my first two terms. 4x squared plus 8x. Give it some space. Minus 2. Now this is a little bit different. My leading term is not 1. Remember when we completed the square, we had to have a leading term that was 1. But perhaps I could factor out a value there. So let's factor out 4. That leaves me with x squared plus 2x minus 2. Okay. That I can work with. Half of 2x is 1x, so 1 squared is 1. But let's be careful to think about how much we've really added to this side of the equation. If I were to distribute 4x squared, 4 times 2x is 8x. Well, those two match, don't they? What about 4 times 1 plus 4? Notice, despite the fact that I have a 1 sitting here in my perfect trinomial, when it gets multiplied by the 4, I have really added 4 units to the right side of my equation. And so the only way to keep this equation balanced would be to subtract 4 units from somewhere. So I'm going to go ahead and subtract the 4 units outside the parentheses. Now we can create a binomial squared out of our perfect trinomial. So x plus 2, that's going to be x plus 1 squared. Bring down the 4. Combine my like terms. -2 and -4 becomes -6. And we have created the vertex form. All right, let's do vertex form again. I'm going to parentheses around my first 2. We have -x squared plus 6x. Give myself some space. -3. Well, I have a -x. Can't have a -x, so we're definitely going to have to pull out that negative. So that will leave me with x squared minus 6x minus 3. Okay. Half of -6 is -3. -3 squared is +9. And again, before we do anything, let's figure out what this negative is going to do to that. Negative times x squared is -x squared. Negative times -6x is +6x. So notice very little has changed in the original equation. Negative times +9 is -9. So what have we really added to the right side of our equation so far? We've added a -9. So in order to keep our equation balanced, we need to add a +9, and we're going to add the +9 outside the parentheses. This will give me the ability to make a perfect trinomial become a binomial squared. So x minus 3 squared. Remember, I still have the negative outside, and combine our like terms. -3 and 9 becomes +6. Hopefully you're going to see that these will start to get a lot easier the more you do them. Go ahead and take a moment to pause the video, solve this one on your own, and then come back and check the solution. All right, welcome back. So we have x squared minus 5x, that's going to be my parentheses, plus 10 outside the parentheses. My leading term for in front of x squared is a 1, so that's good. Half of -5 is 5/2 squared. Now, you're welcome to square it out. You can say 25/4. That's not going to hurt my feelings. So we've added 25/4 to the left side of the equation in order to make sure that we keep this equation balanced. Hopefully you remember to subtract 25/4, and we're going to do that here. So let's put this together. We have x squared minus 5 plus 5/2x. The reason why I did the 5/2x is because I know I'm going to break this down. And when we break it down, we're looking for what value was here before it was squared. So x minus 5/2 squared. So we should see that when I multiply x times x, I'm going to get x squared. When I multiply x times -5/2, I get -5/2 twice. So I add the -5/2 and the -5/2. And I get -10/2, which is actually -5. And then when I multiply the -5 squared, I get +5/2 squared, because a negative times a negative becomes positive. So far we're in good shape. But I'm going to have to figure this portion out here. So in order to subtract those, I need a common denominator. 4 under 40 is the same as 10 minus 25/4 is equal to 25. That would be 15/4. So we are in the positive because our 10 was greater than 25/4. So plus 15/4. How'd you do? All right, try another one. We want to convert this one to standard form. All right, following our order of operations, you should have first multiplied the binomial. So x minus 5 times x minus 5 is going to give me x squared minus 10x plus 25. Now, this is just my binomial squared. We still have a 3 in front of it. We still have a positive 1 after it. Next order of operation would be distribution. So we distribute 3x squared minus 30x plus 75. Still have the plus 1 outside. Now, I really don't need the parentheses anymore. They're not serving me any purposes. There's no negative sign in front of the parentheses, so they can go away, which leaves me 3x squared minus 30x plus 75 plus 1. So we can combine our last two terms, and d of x will equal 3x squared minus 30x plus 76. All right, let's go to intercept form. In order to go to intercept form, we've got to first go to standard form. I know it's a little bit of a pain, but standard form is your middleman. So x plus 2 times x plus 2. The more you do these, the easier they'll get. So we'll end up with x squared plus 4x plus 4. Minus 64. Again, there is no negative in front of the parentheses, so we can drop all of the parentheses. X squared plus 4x plus 4 minus 64. Where we finally end up with a p of x being equal to x squared plus 4x minus 60. Now, are we done? Not quite. That's standard form, and we were asked for intercept form. So we want to know what two numbers multiply to negative 60 that add up to positive 4. Well, let's see. Looks like we have a 6 and a 10 in some combination. I need the 10 to be larger, so it will have to be positive and larger. So 10 and negative 6. So we have x plus 10, x minus 6. Those are our factors. Equals p of x. And we now have intercept form. All right, let's go to vertex form. In order to go to vertex form, we first need to have our standard form. So let's FOIL 2x squared plus 10x minus 3x minus 15 gives me 2x squared plus 7x minus 15. And now we want to take our standard form and convert it to vertex form. So I'm going to put my parentheses around. 2x squared plus 7x. Give myself some space, minus 15. I can't have a leading term that's greater than, or that's not 1, so we need to divide by 2, and this is going to get a little bit messier. 2 times x squared plus 7 over 2 x minus 15. Well, what is half of 7 over 2? 7 over 2 times 1/2 is equal to 7 over 4. So we're going to add 7/4 squared. Because 7/4 is half of 7/2. So that when we create our binomial, we take that value 7/4, which is half of 7/2, and we end up with x plus 7/4 squared. We already know the 2 is dropping down. And we've got to figure out how to keep this equation balanced. Well, what did we add? We add 7/4 squared, but that number got added in a doubled fashion. So let's do a little math off to the side. 7/4 squared equals 49 over 4. And we need to double that because we have added double the 7/4 squared value. So that's going to equal 98/4. All right. Let's take our 98/4 and realize that since I added 98/4 inside the parentheses, I need to subtract it outside the parentheses. That will keep it 0. So let's change 15 to a number of fourths. 15 would be 60/4 minus 98/4, which is going to equal negative 158/4. Now, negative 158 is negative 158. We could divide it by, looks like 2, and that would simplify down. You can go ahead and divide it by 4 and get a decimal equivalence. I'm fine with that. I generally prefer improper fractions, so let's go ahead and just do that for kicks. Negative 79 over 2, and we are in vertex form. Just add our s of x. All right, let's write a function for the graph in all three forms. Well, what's going to be the easiest form for me to write? Really got a couple of options, but I think probably our easiest one is going to be our intercepts form. So our intercepts form shows us that we have x plus 3, which would be the opposite of negative 3. We have x plus 1, which would be the opposite of negative 1, equals f of x, our function. Now, we should be able to look at the graph and see whether or not it has been vertically stretched or shrunk. We can tell that by starting at the vertex and going up 1 over 1. And if we end up at an ordered pair, we know we're dealing with a standard graph. So, we can figure out our standard form by FOILing. X squared plus x plus 3x plus 3 gives me an x squared plus 4x plus 3. You've got the option now of trying to figure out your vertex form from your standard form, or notice I've got the vertex sitting right here. The vertex is equal to negative 2, negative 1. Those are my h and my k values. So we would end up with f of x is equal to x plus 2, the opposite of x value, squared, minus 1. So it's actually kind of nice when we have a graph because it makes it a lot easier for us to write out the equation. All right, how about this one? Again, I have a vertex form there. I go down 1 over 1, that intercepts, which means we're dealing with a standard non-stretched, non-dilated. So f of x is equal to my intercepts. We want the opposite values, positive 1, so x minus 1. 1, 2, 3, negative 3, so x plus 3. We've now figured out our intercept form. Let's go on to our vertex form since we have a standard graph. So f of x is equal to negative, because the entire graph is a cave, it's flipped over. Our vertex is negative 1, comma 1, 2, 3, 4. So we want to have an x plus 1, the opposite of our x value, plus 4. Now, hopefully that's given you a good sense of being able... Oh, I skipped one. Sorry. Let's figure that one out. X times x is x squared. X times 3 is 3x. Negative 1 times x is negative x. Negative 1 times 3 is negative 3. So we have x squared plus 2x minus 3. There's our standard form. Now, hopefully that's given you a good indication of how to solve quadratics in intercept form, standard form, and vertex form. And you'll get more practice from your worksheets. Have a good day.